This is SpaceTime, Series 22, Episode 21. Coming up on SpaceTime, Crew Dragon 2 completes its maiden mission. How much does the Milky Way weigh? And the new Chinese space station to fly this year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
SpaceX's Crew Dragon 2 has splashed down safely in the North Atlantic Ocean, successfully ending its first unmanned orbital certification test flight. The Demonstration 1, or Demo 1 flight as it's being called, was launched just over a week earlier aboard a Falcon 9 rocket from Launch Complex 39A at the Kennedy Space Center on the Cape Canaveral Air Force Station in Florida. The Demo 1 mission flew to the International Space Station, autonomously docking with the orbiting outpost's Harmony module. The mission allowed engineers to check out the new capsule's equipment under actual end-to-end in-spaceflight conditions as part of the process needed to achieve human spaceflight qualification. The tests included all ground and spacecraft systems, including Dragon's avionics and communication systems, its telemetry, electrical, guidance and navigation systems, its control and propulsion systems, and its environmental and life support systems. The flight also monitored both internal and external loads, vibration levels, and acoustics. After remaining attached to the space station for 116.5 hours, the capsule then autonomously undocked from the orbiting outpost, moving to a safe holding position. Crew Dragon 2 then undertook a series of maneuvers, and 5 hours later undertook an all-important 12-minute deorbit burn, using its 8 Super Draco thrusters to the max to slow down and drop out of orbit.
Dragon has performed its final departure burns from the International Space Station and is on its way back home to us. Today's mission actually began back on March 2nd when Dragon launched from Kennedy Space Center in Florida. Following that successful launch, Dragon arrived at the space station and docked with the orbiting lab on March 3rd. Dragon's return to Earth will mark the third completion of SpaceX's first demonstration mission for NASA's Commercial Crew program. While there are no astronauts on board Dragon today, this demonstration mission represents an important milestone as we approach our first crewed mission later this year. Earlier today, Dragon powered up from sleep mode and began its departure procedures and system checks.
That's right, and then the spacecraft autonomously undocked from the International Space Station at 11:32 p.m. Pacific time. Then it began a series of departure burns to move away from the station. And I think we just heard trunk separation.
Just had confirmation of the deorbit burn.
NASA airplane that were flying around that recovery zone there, a WB-57, commonly used for a lot of atmospheric studies and other science missions, but able to put a tracking camera on it to try and get this re-entry through the Earth's atmosphere today. We're hearing that they should have AOS, acquisition of signal, back with the Dragon spacecraft. Right now it's about 46 kilometers in altitude. Acquired signal about a minute ahead of when it was expected, where we're going to be looking for those initial drogue chute deployments at about 41 minutes after the hours. We're going to be keeping an eye out. You're going to see the drogue chutes deploy initially, followed by those 4 main parachutes, much larger and able to slow the vehicle down. This is Dragon coming home, the landing zone over the Atlantic, about 200 or so nautical miles off the coast of Florida. And hearing we're now about 20 kilometers in altitude. The Dragon spacecraft continuing to descend. It's now subsonic, so already starting to slow down thanks to the aero braking, basically slamming into that Earth's atmosphere, causes a lot of friction and allows the vehicle to eventually reach its terminal velocity, basically. And then those parachutes are going to kick in.
So there you have visual confirmation of the deployment of our drogue parachutes. This is the first of 2 parachute deployments.
So those drogue chutes do the initial slowing, and then they're ultimately going to pull out the 4 main parachutes responsible for really slowing the spacecraft down.
Twin day-glow orange supersonic drag chutes were deployed after emerging from the plasma blackout zone roughly 20 kilometers above the splashdown recovery area. They were followed minutes later by the 4 orange and white main chutes, which gently floated the now charred and stained capsule to a perfect splashdown.
And here come the mains.
Over the next few seconds, we will see those main parachutes begin to expand as they capture more air further decelerating the Dragon vehicle down to the Atlantic Ocean.
And yes, all 4 chutes now deployed. It's going to continue to descend. It's going to continue to slow down and then ultimately splash down in the Atlantic there. We're now under 1 kilometer in altitude. Everything continuing to look good via reports to all the flight control teams. We were planning on splashing down at about 5:45 a.m. Pacific, and we're getting real close to that bingo time.
And we have confirmation that Dragon is now under 100 meters above the surface of the ocean.
Standing by for splashdown.
And there we have confirmation of splashdown. Dragon has returned to planet Earth. It is now back home. And our 2 fast boats racing out to the capsule, now in recovery.
That splashdown came right on time, 5:45 a.m. Pacific, 8:45 a.m. over on the East Coast. The teams that have been ready and waiting, they were staged just a few nautical miles away. They're going to start moving in now. Those 2 fast approach boats already speeding their way towards the capsule.
Fast recovery vessels deployed in the splashdown zone from the GO Navigator Recovery Support Vessel then raced towards the capsule, quickly safing the bobbing spacecraft's volatile components. Shortly afterwards, the transport recovery vessel GO Searcher hoisted the capsule aboard and returned to Port Canaveral. GO Searcher will be SpaceX's primary capsule recovery vessel. It features a medical bay for returning astronauts and a helipad for immediate return to shore. SpaceX's current plans involve hoisting the capsule aboard GO Searcher before opening the hatch and extracting the crew. But that operation took an hour in what were relatively calm Atlantic seas. The company hopes to eventually get that down to less than half an hour. If further tests, including an in-flight abort test, which will now definitely take place in June, are successful, a 2-person crew will ride aboard Dragon on its second demonstration flight to the space station, most likely in July. And if that proves successful, regular crew transfer flights could begin before the end of the year. And that's important, because it will finally end America's reliance on Russian Soyuz rockets to reach the space station, in the process signaling America's return to launching people into orbit off American soil. And that's something which hasn't happened since the mothballing of the Space Shuttle fleet in July 2011 with the return to Earth of Atlantis on STS-135. You're listening to Space Time. I'm Stuart Gary. A new study has determined that the Milky Way galaxy contains at least 1.5 trillion times the mass of the Sun. The new figures, taking into account everything within 129,000 light-years of the galactic centre, are based on data from NASA's Hubble Space Telescope and the Gaia mission. Working out the mass of the Milky Way is one of the most fundamental measurements astronomers can make about our galactic home. However, despite decades of intense efforts, even the best available estimates of the Milky Way's mass have disagreed widely. Previous estimates, which we've covered both on SpaceTime and its predecessor Star Stuff, gave masses for the Milky Way ranging from 500 billion to 3 trillion times the mass of the Sun. This huge uncertainty has arisen primarily because of different methods being used for measuring the likely distribution of dark matter within our galaxy. Dark matter is important because it makes up some 80% of all the mass in the universe, and even larger percentages around galaxies. The study's lead author, Laura Watkins from the European Southern Observatory, says the problem is scientists simply can't detect dark matter directly, and that's what's led to the present uncertainty of the Milky Way's mass. The thing is, you simply can't measure accurately what you can't see. And although we know dark matter exists, it appears invisible to us, interacting only gravitationally with normal matter. Given the elusive nature of dark matter, which could make up to 90% of the mass of the Milky Way, astronomers had to use a clever method of weighing the Milky Way which relied on measuring the velocities of globular clusters, dense spherical balls of ancient stars which orbit around the galaxy's outskirts. Globular clusters contain thousands to millions of tightly gravitationally bound stars, which were all originally born at the same time in the same collapsing molecular gas and dust cloud. Because of their great distances, globular clusters allow astronomers to trace the mass of the vast envelope of dark matter which surrounds our galaxy far beyond the spiral disk. The more massive a galaxy, the faster its clusters move under the pull of its gravity. Most previous measurements were recording the speeds at which a cluster was approaching or receding from Earth, that is, the velocity of the cluster along our line of sight. However, this new work was able to also measure the sideways motion of clusters, and that allowed astronomers to determine each cluster's total velocity, and consequently a better estimate of the galactic mass could be calculated. The total velocity of an object is made up of three motions, a radial motion plus two defining the sideways motions. The problem is in astronomy, usually only line-of-sight velocities are available. And with only one component of the velocity available, the estimated mass would depend really strongly on the assumptions for sideways motions. Therefore, measuring the sideways motions directly significantly reduces the size of the error bars for the mass. The authors were able to use the second data release from the European Space Agency's Gaia spacecraft as the basis for their study. Gaia was designed to create a precise three-dimensional map of astronomical objects throughout the Milky Way and to track their motions across the sky. Its second data release has included measurements of globular clusters as far as 65,000 light-years from Earth. Because globular clusters extend out to such great distances from the galactic centre, they're considered the best traces astronomers can use to measure the mass of our galaxy. The authors then combined this data with the unparalleled sensitivity and observational legacy of NASA's Hubble Space Telescope. The observations from Hubble allowed scientists to see beyond Gaia, providing observations of faint and distant globular clusters as far as 130,000 light-years from Earth. These could then be further added to the study. And as Hubble had been observing some of these clusters for a decade or more, it was possible to accurately trace their velocities as well. So, by combining Gaia's measurements of 34 globular clusters with measurements of 12 more distant clusters by Hubble, astronomers could pin down the Milky Way's mass in a way which would be impossible without these two telescopes. Until now, not knowing the precise mass of the Milky Way has always presented a bit of a problem for attempts to answer an awful lot of cosmological questions. The dark matter content of a galaxy and its distribution through that galaxy are intrinsically linked to the formation and growth of structures across the universe. Accurately determining the mass of the Milky Way gives astronomers a clearer understanding of where our galaxy sits in a cosmological context. This is SpaceTime. I'm Stuart Gary. China's Xinhua News Agency is reporting that Beijing will launch the core module of its new space station before the end of the year. The announcement comes almost exactly a year after the uncontrolled atmospheric re-entry of China's first experimental space station, the Celestial Palace, or Tiangong-1. The wildly out-of-control spinning, flaming wreckage of the space station eventually crashed into the southern Pacific Ocean just northwest of Tahiti. A second prototype space station, Tiangong-2, was launched in September 2016, and it's expected to be deorbited, hopefully under control, later this year. The new Chinese space station will use a core module to be known as the Harmony of the Heavens, or Tianhe-1, which will provide guidance, navigation, and station orientation control functions, as well as life support and living quarters for up to 3 crew members. The design of this core module will be based on the designs of the Tiangong-1 and 2 space stations. In fact, Beijing are so happy with the design, they've also been using it for the Tianzhu, or Heavenly Vessel, cargo ship. Beijing says the new orbital outpost should be completed and operational by 2022. The core module is slated to launch aboard the maiden flight of China's new Long March 5B rocket from the Wangcheng Satellite Launch Center on Hainan Island in the South China Sea. The Ariane 5 rocket's first launch for 2019 has placed 2 telecommunications satellites into orbit. Ariane Space Flight VA247 blasted off from the European Space Agency's Kourou spaceport in French Guiana, carrying the Saudi geostationary satellite 1 Hellasat 4 and the Indian GSat 31.
9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des EAP, décollage Ariane VA247.
Local time and right on time.
La propulsion est nominale.
Mission, lifting off from the ground here in French Guiana with a lot of fire, carrying 2 new satellites. The two boosters now providing 90% of our thrust, propelling the launcher along her trajectory at an ever higher velocity as the DDO says all is working perfectly on board. Our mass at liftoff, 775 tons. And to get that sort of weight off the ground, you need a lot of push, and push we have. She's burning 5 tons of fuel every second. That's 2.5 tons per second burning in each booster, plus the core stage burning another 300 kilos of fuel, again every second. Ariane 5 is now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see in less than a minute. The DDO says all is working fine on board. We're in the first of 4 flight phases as she heads east across the Atlantic. Right now, the first flight phase, the single first stage engine and the 2 boosters are burning. The boosters will each consume their 240 tons in just over 2 minutes. In about 20 seconds, they will be extinguished, and they're the first to be jettisoned, and you'll hear that from the DDO. This first flight phase using both cryogenic cold fuel and storable propellant. Cryogenic offering certain advantages over storable, better and more precise performance, and its motors can be reignited. There we have right on time separation of the 2 boosters. The DDO confirms it. They fall 500 kilometers from shore into a protected area. French Guiana was in part chosen as a base for its opening on the water, launches posing no threat to the local population. Our altitude approaching 100 kilometers. Our speed, we've passed 2 kilometers per second. The speed we need for satellite separation, roughly 9 kilometers per second. Fairing separation has come right on time. Separation given by 2 pyrotechnic systems, one horizontal and one vertical. They're cords that actually remove the fairing by a small contained explosion, and we emphasize contained, of course. We can separate the fairing now because we are out of the dense layers of the atmosphere. Over 100 kilometers up, there's neither friction nor heating, which could disturb the passengers. Also, we can discard any dead weight when possible to maximize the launcher's performance. The fairing weighs 2.5 tons, so it's good to get rid of it when we can.
The 6,495 kilogram Saudi geostationary satellite 1, Hellasat-4, was the first to be released about 27 minutes after launch. This is a joint mission between Saudi Arabia and Arabsat subsidiary Hellasat, providing Ku-band telecommunications coverage over Europe, the Middle East, and South Africa. It was followed 15 minutes later by the deployment of the 2,536 kilogram GSAT-31, which was launched for the Indian Space Research Organisation to provide additional Ku-band satellite communications for the subcontinent. As well as being the first Ariane 5 mission for the year, this flight also marked the 103rd overall Ariane 5 mission and the 70th mission using the heavy lift ECA version of the Ariane 5. And time now to take a brief look at some of the other stories making news in science this week with a science report. The Bureau of Meteorology has officially declared the last 3 months as the hottest Australian summer on record. The findings are in line with global warming predictions, which also warned of increasing numbers of extreme weather events such as floods, bushfires, ongoing drought, and persistent heat waves. Weather Bureau climatologist Dr. Lynette Petio says unprecedented heatwave events during December and January played a major role in summer being Australia's warmest on record. She says there was a noticeable absence of strong cold fronts that would normally bring relief during summer, mainly as a result of persistent high-pressure systems sitting over the Tasman Sea, blocking those fronts from impacting the south of the country, especially during January. For the country as a whole, it was also among the 10 driest summers on record. In fact, only parts of northern Queensland and northwestern Victoria had above-average rainfall for the summer period. Danish researchers have found further evidence that the measles, mumps and rubella vaccination does not increase the risk of autism. The new research, reported in the journal's Annals of Internal Medicine, also found the vaccines do not trigger autism even in more susceptible children. The nationwide study looked at all Danish kids born between 1999 and 2010. That's more than 500,000 in total. It found the MMR vaccine does not increase the risk of autism, even in kids with other autism risk factors or in kids with siblings who have autism. There was also no clustering of autism cases following vaccinations. The false claims linking autism to the MMR vaccine are based on a discredited and now retracted study by the former British doctor Andrew Wakefield. An accompanying editorial in the Annals of Internal Medicine suggests this additional evidence still won't be enough to convince anti-vaxxers, and that doctors should be using the approach to misinformation developed by Australian experts in the Debunking Handbook. A stem cell treatment has put an AIDS patient's HIV into remission, marking only the second ever case of HIV remission. However, a report in the journal Nature cautions that although the patient's now been in remission for 18 months, it's still far too early to say whether that patient has been cured of HIV. 10 years ago, another patient, simply known as the Berlin patient, had his HIV sent into remission by a similar treatment, but numerous attempts to replicate that procedure have failed to work. This second patient received a transplant of stem cells from a donor with a genetic mutation that prevents the expression of an HIV receptor, CCR5. At the moment, the only way to treat HIV is with medications that suppress the virus, which people need to take for the rest of their lives. Worldwide, more than 37 million people are now living with HIV, but only around 59% are receiving antiretroviral treatments. That's mostly in Western countries. And drug-resistant HIV is becoming a growing concern. At the moment, almost 1 million people are still dying every year from HIV-related causes. Scientists have discovered an unusual example of rapid plant evolution in action, with confirmation that the South African beach daisy has drastically changed its appearance in the less than a century since it was first introduced into Australia. The findings, reported in the Proceedings of the Royal Society B, show how much the plant's changed since its introduction to Australia in the 1930s. Scientists from the University of New South Wales say when challenged by a new environment and away from its native habitat and herbivores, the daisy's undergone rapid evolution. The beach daisy was introduced to Australia from its native South Africa in a bid to prevent coastal sand dunes from eroding. It's now a common sight along many sand dunes in Australia, with its yellow flowers and distinctive silvery woolly leaves. But rapid evolution could mean both good and bad news. See, the plant's level of change in under a century shows how quickly species can become invasive. But the study also shows that science shouldn't underestimate the adaptability of plants to rapidly changing conditions, such as climate change. Well, since the arrival of the first British more than 230 years ago, most Australians have assumed that dingoes are simply a breed of wild dog. But now 20 leading scientists have confirmed in a new study that the dingo is actually a unique Australian species in its own right. The new findings provide further evidence of specific characteristics which differentiate dingoes from domestic dogs, feral dogs, and other wild canids such as wolves, foxes, and coyotes. The study's lead author, Dr. Bradley Smith from Central Queensland University, says little evidence exists to support the notion that any canid species are interchangeable with dingoes, despite the fact that most canids can successfully interbreed. The study's co-author, Professor Corey Bradshaw from Flinders University, says the classification of dingoes has serious consequences for the fragile ecosystems they inhabit. He says dingoes play a vital ecological role by outcompeting and displacing introduced predators. When dingoes are left alone, there are fewer feral predators eating native marsupials, birds and lizards. We all know that psychics are a con job. Their prognostications are bogus and their profession is a swindle which relies on the gullibility of people. With that being the case, why do so many people still believe in them despite all the evidence to the contrary? Tim Mendham from Australian Skeptics says it's a good question.
It's a big question, actually. I mean, it's probably the number one question that skeptics always ask themselves is why people believe, not so much what they believe, and that's a particular issue as well, but you get deeper and you wonder why people believe certain things or have a propensity to believe certain things. And the one thing you do find out about people who have a propensity to believe in the paranormal is they'll believe in different things almost in sequence. If they believe in thing A, a particular claim, etc., and when it's debunked, they'll move on to claim B, and claim A will just disappear entirely. It never happened, and they'll move on to claim claim B and then they'll move on to claim C, etc. So it is a propensity to believe rather than necessarily what they believe in. And I know people who believe in everything going. One of the reasons is that people feel
powerless?
I was going to thank you very much. Powerless, yes. I think I was trying to think of the word. Powerless about the world around them, that they have no control over how the world reacts to them. And the thing is, of course, that that's true of most of us. You know, when a volcano goes up, you don't really have a lot of power over it, or when a government makes a decision, you might not have a lot of power to object. So that makes people very suspicious, very worried, and they turn to other areas. And psychic powers might be because psychics claim to be 100% accurate. They have a tap into the other world, and they can see very clearly where you can't. There are things that the psychics say which are impossible to validate because they're so vague. The evidence they supply is very mixed and very... most people don't actually look for evidence from psychics anyway. They just listen to what they say and they don't sort of take it any further to investigate. Obviously, there's a mindset of people, a propensity to believe that people bring with them, and don't forget that anyone who goes to a psychic almost entirely is going there because they have a need to fulfill, and so therefore when they go there, they're already half committed.
Did you watch John Oliver on Last Week Tonight?
I did.
On psychics. What did you think?
That was a pretty good hatchet job, actually. And he was pointing out some of the tricks that psychics use, whether it's cold reading or hot reading, right? And cold reading is basically when you're reading body language on the spot, you're sort of trying to get some clues from someone, how someone's reacting to you, someone you've never met. Hot reading is about someone you already know about, you've done some research on them, or you've met them before. In many cases, they are a past client, or they've been recommended by a past client who might give you a lot of information. And as John Oliver was pointing out about some well-known psychics, including the...
I think he mentioned the Long Island psychic and also that little fellow who... I shouldn't say little fellow, he's a grown man. The young gentleman who does all that psychic reading in Hollywood.
Stars.
Tyler, or whatever his name.
And what John Oliver was saying, obviously, as you've just sort of discussed or shown, is that he apparently does his research. People are surprised at how much people know about you when you've already said it on social media or whatever. I've seen this a lot.
Facebook, yeah, exactly.
I've had it exactly that. You know, people have come to me and said, my sister is very much wrapped up in this psychic who has told them all about themselves. The psychic could never have known about all these things about themselves. And so I ask a couple of questions, go onto Facebook, 5 minutes research shows that everything their psychic knew about this sister was already there. And you do a little bit of research and not a lot. It's amazing how much people give away information about themselves on social media. And that's what John Oliver was talking about.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.